Hey guys, welcome back. Cool. So we are starting today with this question. Can you comment your names so I can take a quick register? Um, and I have now updated the registers for Wednesday and well, just for Wednesday for you guys. Cool. Let's just move this down a little. Cool. Right, could you guys give this a go to start with today? So, hypothesis test based on what we're doing last lecture. We'll start with 7 minutes to give it a go, and yeah, go through it in 7 minutes. So please comment your names in the meantime, and if you need any help, comment, or if you've got an answer, comment that as well. Cool, let's get started. Cool. Anyone need any help or any hints? Just comment if you do. Hey Poppy, did going over the other stuff make a bit more sense? Give this one a go and ask me if you get stuck on any of them. Cool. Anyone need any help? Yeah, so draw the distribution. You can do it like that. I think it's better to use Z for it though. Yeah, you'll get a slightly different answer if you just do mu minus 2 sigma. So I would use Z. It's worth 3 marks, so I'd do a bit more than that, Lucas. Oliver, yeah, I think that's correct. Good job. So yeah, part A, you're using a Z distribution to try and find the variance. But yeah, Lucas, well spotted, 'cause it is 95%, so you technically should be able to do it that way. But because it's, yeah, you can't get it as precise with that method. And then part B, we're talking about hypothesis tests, so find the critical region and then find the mean of those things. Is to show that though. Yeah, yeah, I still think they'd want it to be that way around. Because if you've got 5 squared, it's going to be 26. So yeah, you'd probably, yeah, the variance is 26.03. What's the problem? Yeah, so 5 sigma is 5.1. If you square that, you do get 26.03. Because sigma is the square root of the variance. Yeah, sorry. So yeah, the gram squared because it's yeah, square units as well. Sorry, no, there's not a. It's not your bad. Someone else did that in the other group as well. Right, are you guys done, or do you want another couple minutes to do part B? Up to you guys. Another minute or two. Yeah, go on. 2 more minutes because I haven't seen any answers for part B yet. Right, 2 more. Good to go. If you get stuck and need any hints, just comment. How do you mean, Lucas? Never know the x values. Oh, x is the value that you've been given. So you're trying to show that it's between 1000 and 1020. So 1000 and 1020 are your z values. So you've worked z and you need to put x in. X is what would also be on the x-axis of your normal distribution. So z and x share the same axis. It's just one's coded and one's not coded. Yep, 2 z values, and well, you don't need to. You can just solve one of them because you know z, you know x, and you know mu. So yeah, you just need to use one of those. Cool. All right, let's give this one a go then. So yeah, part A is show the variances between those two. So we need to do a z distribution. And I'm going to do a quick sketch of what's going on. Actually, I can get a little bit more room out of this. Let's cool. Oh, maybe I do need more room. Okay, right. So let's draw that again. So there's my curve. We know that 95% needs to be in the middle, so this is going to be 0.95. And these two are 1000 and 1020. We know the mean is 1010. So we're trying to work out the Z values that correspond to 1020 and 1000. And we're going to find those because we know the probabilities for each of these tails is 0.5 in total, so it's going to be 0.025 for each tail. So we can use an inverse normal to find the Z value that corresponds, and then we're going to use Z equals X minus mu over sigma to find the standard deviation, to find sigma. So yeah, Ollie, yeah, you can use central if you want on this one as well. I tend to always just use one of them, but you're welcome to do that. So if I go to inverse normal, distribution, norm, inv, we're going to go to let's go left. So left. Oops, don't look at that. Area is going to be 0.025. The sigma is going to be 1, and the mean is going to be 0 because those are the sigma and the mu for our standardized distribution. So my Z value is minus 1.96, and that's what corresponds to the 1000 you can see just down there. Right, so we're going to then code or uncode everything. So we put Z in, so minus 1.96 equals X, or X is 1000 to correspond with that one. Minus mu is 1010, and sigma goes on the bottom. If you solve that, you get sigma is... What'd you get? Sigma is 2.358. Cool. And if you square 0.2358, you get the value. Probably says, how do you calculate Z values on a class quiz? Same thing again, but the class quiz can only do the less than tail. So you go inverse normal on the class quiz. Yeah, let's show you quickly. Inverse normal. Put in the area, so the area was 0.025, I think. Sigma 1, mu 0. There's your Z value. So exactly the same thing. The only difference is you can only do less than areas, so you need to bear that in mind later on. Right, back to it. So so that's the first bit. Yes, if you square that, you prove that so 2.358 squared is 26.03. So that's that bit done. Part B then. Oh, what we're doing, part B is asking us to do a hypothesis test. So we've been told we got the mean distribution. So if we call it X with a bar on it, is a normal with mean should be the same. So we should still have 1010. Standard deviation now will be let's put sigma squared in. Put the variance in. 26.03 divided by n, and n is 8. So we should get that as our that thing down there as our distribution for the sample means. So we're going to test at the 2% significance level. So let's do a little sketch. Where's 2%? Okay, we're going to try and see if the machine is different. So one of the things is the mean weight needs to be 1010. They're saying test if it's different, if it's not fulfilling that anymore. So we're basically doing a two-tail test. 2%, so it's going to be 0.01% or 0.1% per tail, which is 0.01 in terms of a probability. And we need to find these critical values here and here. Cool. So let's state our hypotheses. So I'm just going to write over the top of the first question. So H naught mu equals 1010, and H1 mu does not equal 1010. So those are my null hypotheses. So we're going to do a sketch on the calculator. We're going to find the corresponding critical values, and then we're going to test whether our mean is inside the critical values. So let's go to the calculator. Inverse normal. We're going to do tail. We'll do left and right separately. If you want, you can do central and do them both at once, which is kind of nifty. So we do left first, area 0.01. Sigma is 26.0 root 26. Root everything this time because it's all variance. 26.03 divided by 8, all square rooted, and the mean is 1010. Cool. So we get a z value of 1005.8. So that's my lower value. There's not actually much space here. Let's see if I can fit it down there. 1005.8. Can you guys see that? Just about. And let's do the upper as well. So I can just change the tail. If you're on the class Wiz, you're going to have to do less than, and it's going to need to be 0.99 because you have to do everything less than this this value here. So everything less than this instead. Whereas we can on the graphical just do greater than. So we're going to change the tail to right-sided tail. Hit equals, and we get 1014.2. You just about see down there. Good. Just to show you what central would do if you push central. It's a nice fast. Oh, hang on, that's not right. Ignore that. Don't use central. If we did central, I think we need to put 0.02 in. No, I don't really know what that's doing. Ignore central. It doesn't seem to work. Okay. So we're going to try and do a test at the 2% level. So, okay. So we got our critical regions. We need to find our test statistic. So we're going to put the data into the calculator like I've already done here. And we're going to use this to calculate the what the mean is. So if we go to calc, make sure it's set up right. So we're going to go set up, make sure the frequency is 1 for list 1. And hit 1 var, which will find us the mean. So the mean here, x bar, is 1013.4. Cool. Okay, is that critical? So having a look at the graph, 1013.4 would fit in about there, which is not critical. So we can say 1013.4 is less than 1014.2, therefore not critical. So because of that, we're going to reject H1, accept H0, and say the mean has not changed. Machine meets condition 2. Cool. Anybody got any questions about that? So finding critical regions, Find the mean, test if the mean lies inside critical regions or not. Everyone okay? Okay, let's move on to the next one. Oh no, that's that. Okay. So the plan for today mainly is to go over everything so far and give you guys a nice way of seeing whether it's a binomial question or a normal question. So we're going to try and look at a few questions so that you can get a kind of flavor for when it's normal, when it's binomial, when you should be approximating, when you should be doing this, that, and the other. So that's the goal for today, and then that will kind of finish off this topic. And then after Easter, we'll have about 2 more lectures on the correlation hypothesis test that I mentioned on Wednesday. Cool, and I've shown you guys where to find the assignments. The other thing is Wednesday's lecture we had all those technical difficulties, and I think I had hiccups, and so technical hiccups and literal hiccups. If you guys do want to go over that again, I did it yesterday morning. I think lecture 2 on Thursday, so you can find that on the YouTube channel, and it was much better. Yeah, just a better lecture. So if you want to look through that, if you did find Wednesday confusing, I would advise rewatching Thursday morning's version of the Wednesday lecture. Cool. We should be getting some more guidance from the government about your results next week. So after Easter, we should have some feedback for you guys. Cool. Is this still? Okay, there we go. All right. So this is our thing for today. All right. So what's? Oh my God, what am I doing? Cool. Okay. So the idea, what kind of distribution is it? All right. So I'm just going to talk you through how I'm able to kind of spot what's going on in each question. Hopefully you guys can pick up on it too. So our binomial distribution is always to do with the number of trials, and the trials relate to a probability. So you'll have a number of things. It'll be a sample size, and there'll be a probability of success, and the samples will either be successes or they'll be fails. But it's always with a number of things. It could be number of cars, number of people, number of light bulbs, number of anything. Normal distribution, however, the numbers are a mean. Rather than it being a number of objects, in this it's the number of means, or the number of... It's a bit more related to an actual variable. So if you normal distribution, you've got mean and sigma, and if you've got n, which is a number of something, it'll normally link to the size of a variable, because we're always talking about means with the normal distribution. So any mention of mean is likely one of these ones. Any mention of probability is one of these ones. You often see with our binomial questions, you'll see the words at least, at most, stuff like that, whereas with a normal distribution, it would be greater than, less than the value. So this will be at most 5 people, at most 5 wins, at most 5 successes, whereas with normal, it'll be the value is less than this, the value is more than this. So you'll be talking about how a variable changes, whereas with binomial, talking about how a number of things change. So number of things, some kind of value of something you could measure, measurable things, number of things. And it's because continuous variable, discrete variable. So if it's something that couldn't be discrete, it's got to be normal. And if it's something that's discrete, it's probably not normal, it's probably binomial. So that's how I'd always try and think about these. Next bit people sometimes struggle with is when to use Z. And a few of you commented this when we were doing the question. So you always have to use a Z distribution. By Z, I mean the standard normal distribution, the one with mu is 0, sigma is 1. So you use that when you're trying to find the mean, or when you're trying to find the standard deviation, or both. So that's the main time when you guys will end up needing to use the Z distributions. And when should you use the normal approximation to binomial? When it tells you to use a suitable approximation. So that should be pretty obvious, those ones. These ones never need mu or sigma, and the rest should be pretty easy to spot the difference between your normal and your binomial. So we're going to try a load of these today. I thought we'd start off with this one, which is pretty straightforward actually. So it's a 4 marker. It's just asking you to do a hypothesis test like we did just now, just so you can get some more practice in on this. 4 minutes. Can you guys give this a go? And comment if you need help and when you think you've got a correct answer. Cool. Yeah, let's go through this. So, yeah, Ollie, cool. 11.1 was what I got, so good. Wait, 11.9? I got 11.1. Um, oh, 11.1 was the thing. 11.15 I got. I think you've done it the wrong way around, perhaps, because you want to find less than. But yeah, we'll go through this. So, daily mean temperature in Herne is modeled normally distributed, blah, blah, blah. So let's do the distribution. Use T to T is normally distributed with a mean of, well, if we read through for the mean, we know sigma is 2.3 squared. It's got a random sample of 20, so the mean distribution is going to have, oops, forgot the letter N in that one. So we'll have sigma as 2.3 squared over 20. Read through, so given the mean samples, that's our sample means 11.1, test at 5%, whether the daily mean temperature is less than 12. So 12 is our mean in both of these. And we're testing whether it's less than this. So H0, mu is 12, H1, mu is less than 12. And we're looking at 5% level, so that's going to be this bit here. It's going to be 0.05. That's our critical region up here. That's what we're doing. See, Ollie, I don't think your critical region is right. I think you've done up here, but it's less than, as you can see, over there. Less than. All right, so get the calculator up, and we go to dist, norm, invna, tail to the left, area 0.02, 0.05, sigma is 2.3 over root 20. Yeah, that's what I reckon too. And mu was 12. So we get 11.15. So that's our critical value. 11.15. Cool. Okay, well, our value was 11.1. So 11.1 is going to be critical, because 11.1 is less than 11.15. So therefore, reject H0, accept H1, and then we can say there's data to suggest that the mean is lower. So mean is lower. Why are the hypotheses those? What do you mean there, Lucas? Why are those the hypotheses? Well, we're testing whether the temperature is less than 12. So 12 is what we're assuming. 12 is what we're assuming, and then less than 12 is what we're what we're testing. No, because that's the mean of the sample, of the sample, of the sample. The mean of the sample, the mean of the population is what we're assuming. So you always assume that the sample should have a similar statistical mean to the population, but the sample mean is, this is what you're testing, this bit. So this is the test we do down here. We're testing if that could be from this population. So the whole thing is, you have a population. Here's your population up here. This is the population. This bit here. From the population, you take a sample. Samples mean is here. The sample mean should be part of this distribution, which is a distribution of sample means. If it's unlikely, which is what we found that there's a less than 5% chance it's likely that the mean of 11.1 comes from this sample mean distribution. What that tells me is that this can't be true. The mean has to be less than 12. So that's how the whole thing works. You're testing whether a sample mean is likely to come from a sample mean distribution, which is based on the mean that they stated. Right, anyway, moving on. Next one we're going to do is this one about snakes. So if you guys could give this a go. So got the length of adult male rattlesnakes. Let's have a talk through this one, see if we can work out what it's asking. So the first bit, given 5%, actually, yeah, 3 minutes, you guys have a think. I want you to try and come up with what part A, part B, part C, and part D are actually asking you to do. What kind of a question are they? Let's see if you guys can identify it. So 3 minutes to do that, and then we'll spend a bit longer actually doing it. Cool, give it a go. Cool. Right, yeah, a few good suggestions there. So part A is asking us to find the mean. So because it's find the mean, obviously we need to use Z. So use Z, find mu. Part B is a binomial, as yeah, nicely spotted there, Lucas. So binomial, because it has a number. Cool. Um, okay, and then we got a Z hypothesis test, and then part D is to do with that as well. So then we got normal hypothesis test. Cool. All right, so that's worth 7, 8, 9, 10, 12 marks in total. I'm gonna give you guys 10 minutes. I think you can do it in 10. So if I set a timer for 10, give it a go, see if you can do it. Comment your answers when you get them, and we'll see how you get on. Yeah, that looks good to you too. Good job, guys. Keep going. Good work, everyone. Keep going. Everyone seems to have been on the right track so far. So let's see if you can get the rest of it sorted. That's close, Lucas. I got 0.5242. So have a look over it. You might just be slightly out. That could be to rounding, but not sure. Check your accuracy of your other answers. Yeah, 0.5576 was what I got. 5556. Hmm. Check that through again. You're slightly up. 5576 was I got rounding to 4dp, but yours doesn't round to that. Um, Hmm. Yeah, we'll see. I can't actually see from my workings whether that's a rounding thing or not. It could be a rounding thing. Yeah, one of you's above, one of you's below. I mean, what did we say for... Yeah, I expect there would be. Let's go through MB and I'll give you guys another couple minutes to do C in a minute, but I want to get to the bottom of why these answers are slightly different. So, given that 5% of rattlesnakes, so let's do the distribution. So we got L is normal with a mean of, I'm trying to find mean, I mean, sigma 0.4 squared. I mean, 5% of rattlesnakes have a mean of less than 1.7, so this is 0.05. So we're finding z, and then using z equals x minus mu over sigma, so calculator. Backwards and inverse to the left, yeah, 0.05. Sigma is going to be down as 1, and mu is 0. So we should get z is 1.645. Okay, so z equals x minus mu over sigma. So minus 1.645 equals 1.7 is x minus mu divided by sigma, and sigma is 0.4. So if you rearrange that, you should get that mu is 2.358 on that one. Which we all got. So next bit is binomial. So 10 are chosen at random. So we got x binomial, n is 10, and probability of success we need to work out. So we need to work out what p is going to be in there. And to do that, we want to find the probability the length is greater than 2.3. So probability x, or probability the length L is greater than 2.3. So we're going to use our distribution from the top there with the bit we just worked out. So this is an NCD question. So the lower is going to be 2.3, upper anything big. Sigma is going to be 0.4, and mu is going to be 2.358. So yeah, we should get the probability as 0.5576. Yep. Which we write in here, 0.5576. And then we can do our binomial distribution. So for binomial, we want the probability x is at least 6. So back to the calculator. Distribution, binomial distribution, BCD, lower 6, upper, well, we've got 10 in total, 10 snakes. Number of trials 10, and probability of success was what we just worked out, 0.5576. Cool. So you should get 0.5412. So please let me know where you two went wrong, or not wrong, but where you two, if maybe you did go wrong, but can you tell me what was different in your workings? Because I can't see how that would have round as much as you guys got, but maybe if you used different probability. Anyway, once you've done that, I'll give you another 5 minutes to finish the hypothesis test in this one. So time starting now. 5 minutes. Please comment if you need any helpful tips. Sorry guys, I keep doing that. Okay, so yeah. Sorry guys. Yeah. So there's my population is the top one. Reading through the text. The the second one is our sample mean distribution. Remember we divide by n. And that's what we're going to be hypothesis testing on. So 5% level. Read state our hypotheses. So let's do that down here. So H0 mean is still 1.9 and H1 we're checking if the mean is not equal, so it's two-tailed again, not equal 1.9. So two tails, 5%, so we're going to do 0.025 per tail. Find the critical values, and that's what it wants us to do for part C. And for the next bit, it wants us to do check if 2.09 is a critical value or not. Okay, so get the calculator out. And we are doing inverse again, so inverse normal. Let's start with the left, so 0.025 sigma 0.3 over square root of 20, and mu is mu is 1.9. So the lower one, 1.769. Yep, Oliver just got it in there in time. 1.769. And the upper, if we go back, all we need to do is change the tail to the right on the graphical. If you're on the class whiz, do 1 minus the area and use that as your lower. We get 2.031. Yeah, whatever. Okay, so to get rid of the calculator again. So those are my critical values over here. Okay, and we are testing is 2.09. Sigma was just a 20 square rooted because I used, if you imagine the variance poppy is 0.3 squared over 20, the standard deviation is 0.3 over root 20. So I'm squaring the top and the bottom, but because we've written a squared sign on the top, we just get rid of that squared sign. So it's just the root. Should I check that? Maybe I did type it in wrong. Let's just double check. Sigma should be 0.3 over root 20. Yeah, it's fine. Cool. Always worth checking. Okay, so yeah, is our rattlesnake critical or not? So 2.09, yes, is critical because this one is 2.03. So 2.09 would be in there somewhere. So we can say 2.09 is greater than 2.031, therefore critical. That word says critical. Sorry, I haven't moved the thing down. Therefore, accept H1, reject H0, and we can say there is evidence to suggest the mean is different to 1.9. All right, anybody got any questions about that one? So we've got about half hour left today. I think there's 2 more I'd like to get through, if that's possible. Okay, let's move on. So next one we're going to do is the one about vans. Here you go. So a company, let's do the same thing as we did last time. Can you guys first of all take 3 minutes to see if you can work out what this question is actually asking you? So 3 minutes on the clock. What is each bit wanting? And then we'll try it in a second. All right, guys, what do you reckon then? How are we going to do each bit of this? So, part one then is a standard kind of find a probability. So it's greater than, but it's just you can do that on the calculator. So it's just a basic normal question. Part B is going to be binomial. Part C is an inverse normal, but nothing weird about it. And then part D is, or part 4 and 5, as I should say, is your hypothesis test. Cool. Can you guys give those a go then? How many? A lot of marks. I reckon 10 minutes should be enough to do the whole thing pretty comfortably. So let's go for 10. Comment if you get stuck or need any help though. Yeah, part one looks good. Part two, yeah, I agree with both your answers there. Good job so far. No, I think your part three is wrong there, Oliver. Have another look at that one. Um, no, still quite a bit out of those ones. It should be on the order of 18,000 and something. Yep, Isla, that is correct. Well done. Cool, you guys are right. Yeah, 1818. Wait, 18194.6 should be the answer. Yeah, that's the one. And last bit is the hypothesis test. I might give you guys another couple minutes because it looks like you're close to getting there, but not quite there yet. So here's the timer. I'll stop it when somebody gets it. Cool. All right. Let's go through this one then. Right. So probability x is greater than 25,000. So we've got let's write out our distribution. So x normal 27,500 and standard deviation 4,000. So that's our distribution. So we're just going to type into the calculator to find greater than, to find the other bit. So calculator. And we're going to go to the, x is greater than it, so we're going to go to the right for this one. So area is, no, we're not inverse, are we? Distribution, normal, and CD. Okay, lower is going to be 25,000. So we've got a nice big number for this one. Sigma 4,000 and 2750 for that one. So you should get probability is 0.734. Nice and easy. That would not be worth 4 marks anymore. This is from the old A level. Okay, now we've got the binomial part. So 10 vans are selected from random in the fleet. So we've now got x binomial 10. I should probably use a different letter really. Let's use y. So y is a binomial, n is 10, and the probability of success is a probability it's more than 25,000, while that we know is 0.734, and we want to find the probability x equals 7. Okay, so we're going to go on to our binomial distribution on the calculator. Give me 2 seconds. I've broken it. Okay. Yep, 2, 2. Oops. Okay, we want to go to distribution, binomial, BCD. Oh no, we want BPD because it's equals 7. So distribution, binomial, BPD. X is 7, number of trials is 10, and probability of success is 0.734 because it's the same probability as we found already in part A. So if you execute that, we get 0.259. Cool. Right, and the last kind of the last bit there is to work. Oh, what am I doing? Sorry, I'm breaking my calculator here. That's better. Cool. Last bit is probability. Find the tires 90. Yeah, okay. So we need to draw this really. So we got 99% is greater than k, so 0.99. So if you're on the class whiz, look at this bit with 0.1. If you're on the graphical, look at this bit with 0.99. So we're going to go to distribution, normal, inverse normal because we know the probability. So tail for me is on the right. I'm going to use 0.99. Sigma 4000. Yep, and that one is that. Hit enter 18194.6. Okay, so that's all the kind of the basic bits done. What we're going to look at now then is this hypothesis test. So if I clear the screen of everything so far, cool. I might make that slightly bigger as well. Okay, so we need to know the mean still, which is 27,500. The rest of this not really relevant anymore. But you would like to see it, I guess. So x normal 27,500 and the standard deviation was 4,000. So now we're looking at the sample mean distribution. So x bar, same mean, 4,000 squared over n, and n is going to be 15 vans for our sample. Null and alternate hypotheses then. So we'll have the null h0 mu equals 27,500. h1 mu is greater than, I think, for this one. They're saying it's better. Yeah, greater mean lifetime. So mu is bigger than 27,500. So we're trying to find the critical region. Again, we just want to find this upper critical region this time. And we're using a 5% level. So this is going to be 0.05. So if I bring the calc back up, inverse normal, area 0.05. Sigma is going to be 4,000 divided by square root of 15. Mu is the same. Work it out, you get 29198. Okay, so that's our critical region. So it's critical if it's more than 29198. So x bar greater than 29198. Our test statistic was 28630. So 28630 here is less than 29198. So therefore, not critical. Therefore, accept H0, reject H1. We can say evidence suggests the mean has not improved. So you could say the manufacturer's claim is incorrect. Manufacturer's incorrect. Cool. All right, is everybody okay with that? So we've got that's it for today. Cool. So yeah, that's well. Actually, I might just leave you guys with one question to take a picture of because we didn't really practice this bit again. I'd like to have done this question. It's in the textbook. It's actually in the paper. There's a mock paper at the back of the textbook. So if you guys could do this, and if also you could fill out the assignments on Moodle skills checks. One's due today, so I'll be marking it probably Monday, to get that filled out. And yeah, just keep working your way through those, work your way through the revision. Apparently next week we'll have some more guidance on what's going to happen with the exams, because at the moment we don't know. So yeah, and yeah, have a nice 2 weeks, 2 weeks at home. Email me if you need any help, and I will at some point try and do a one-to-one, just like a Teams chat with each one of you to go over your mechanics tests. Other than that, cool. Let me know if there's any questions, but I've got to log off because I've got another lecture starting now. So email me if you do need anything else. Cheers, guys. Bye.